Just record the meeting. For the record, it's already recording.
Okay.
Louis Armstrong, but
I should have asked the question. I mean, I have it done, but I should have checked if it was right.
What's your question, Jacqueline?
Well, okay, for E and F, if I hold on, let me pull it up. For E and F, it was like at 1/2. Oh, this is not it. Where's the page? Oh, here it is. Yeah.
3.1 at the bottom when you scroll down to the second page.
Okay. Yeah, E, it says 1/2, so it's not a whole number like the other ones. So like I
So
didn't
you
know.
draw the first ring and then you just don't draw it all the way out to the
Oh,
first.
so is it like this?
Is that your E?
Yeah.
Sort of.
Like I don't know how to draw that.
Let me. Like, yes, but just don't have it go all the way out to that first ring. Like you want it kind of in the middle of the ring since it's only halfway.
You mean like the point?
Yeah,
Not to go out.
all the way to the ring. Yeah, just halfway to the ring. That's the 1/2. That's the radius part.
Oh, I see. Okay, so like
Yes.
okay, and then for
What was the angle for that one? 1/2 what?
5 pi over 4.
Okay, yeah, go ahead.
And then for F it was 4/5. So it'll be that like it'll go 4/5 away.
Yeah.
Oh, okay. So then should the circle go all the way around? Because I drew like this, a half circle.
Yeah, you can make the circle go all the way around.
All right, cool.
Okay, so I'm pinning your video for a second so that you can go ahead and
Oh my God, this
present
is
your problem.
spotlighted. That's so weird. Okay.
Yep. Go ahead and present your problems. The people who aren't ready will catch up on it later. Go ahead.
Okay, so for mine, I did exercise 10A1, and it's pretty simple. You just figure out where the point is on the unit circle, and then whatever Z is the amount of rings you draw around the like with the point. So the first one was pi. So we know pi is, I don't know if I can say, yeah, right here. So and the Z was 1. So there's 1 ring, and then it hit pi right there.
Perfect. And then the next one?
Okay, so the next one was 2, and it was pi over 2. So I drew the ring right there. And then the next one was 3. So I did 3 rings. Yeah, I did 3 rings. And it was 5 pi over 3. And then, oh yeah, I don't know. Do you guys get what I'm saying?
Does that make sense to everyone?
Yeah.
Like,
So whatever your radius is the number of rings. That's how you're measuring how far distance-wise you're going out.
but then for
Your unit circle. So whatever the angle is, you go to the same spot where it would be on the regular unit circle.
and then for E and F, since they're fractions, like the Z is a fraction, so your point would only go like the amount fraction out, so it wouldn't actually hit the ring. So for E, it's 1/2, so your point would go 1/2 out to the ring, but it'd still be in the position of 5 pi over 4, like the one it tells you.
Any questions for Jacqueline on the first question? Okay, who has question number 2?
I think that's me.
Okay.
Jacqueline,
I don't have a problem. Well,
can you send a photo?
Yeah, I got you.
Thank you.
Do I need to skip you real quick?
absolutely. I think I've learned to specifically make sure I actually know. I've learned to. Okay, so. Yeah, sure.
Okay, you should be able to just use your finger to write on the screen.
Okay, so okay, so for number 2, I used the following formula. Right? R is equal as an R. Is equal to the square root of x squared plus y squared, and then for cis of theta, I did the tangent inverse of y over x. Boom. Okay, so from this, I essentially just plugged the formulas for number 2 in the equations from number 2 into this formula. So for example, for 2a, z is equal to 2 plus 2i. So r, that would be 2 squared plus 2 squared, m is the square root of 8. So z would be equal to square root of 8. And then okay, so then we have the tangent inverse of y over x. For this one, I then got pi over 4, and x and y are just a and b, so a is x, b is y. So the 2 would be the x, and the 2 would be the y as well, because it's 2 plus 2y. So I essentially applied this method to all of these. So for example, so the second one to be with of a 2 z is equal to 3/2 over I. So this one would be z. Oops. Z is equal to so I would do 0 squared plus 3/2 squared, which gave me the square root of 9 over 4. Then do y over x again. This one gave me pi over 2. And I said, yeah, so that's why that's what I did with the rest as well. Sustainable or right?
Yeah, you can.
Okay.
Does anybody have any questions?
So I have a question.
Alright.
So, in the formula, is it theta or CIS?
It's just theta.
It's theta. Okay, so yeah, I mean, okay, so so I
It's just
mean,
theta equals tan inverse. That gives you the angle, and then when you're writing out the r, it says theta, that's what he was writing out.
yeah. And I mean, just for reference point, this you're essentially finding r cis theta just for reference. This is essentially what
Make
you're
sure
finding.
you're paying attention, Jacqueline just experienced this as well on Delta Math. Make sure that you're paying attention to the signs of your A and B, because that affects your angle.
Yeah.
So that's just your reference angle. That angle might vary depending on the signs of A and B, if they're positive or negative. So just make sure you're paying attention to those. And remember your quadrants, that in the first quadrant, if your A and B are both positive, it'll be just your reference angle.
Right.
If it's in the second quadrant, it is negative positive. So if your A is negative and your B is positive, then you do pi here, pi
Right.
minus the reference angle.
But
Down here is pi plus,
that,
and that's
then
negative,
that would be
negative.
2 pi minus the value, right?
And then this one is pi plus the reference angle. And
Right.
then the last one is positive, negative, and that is 2 pi minus the reference angle.
Right.
So just make sure you're paying attention to the signs as you go, because your calculator will only tell you the reference angle.
Yeah.
You have to determine which angle you need to use. Great,
Right.
thank you, Leonard. Next, number 3.
So I got number 3. Mine is pretty straightforward also. So we have the system equation of x equal to r sine, oh, that's not it. R times s of theta and y is r times this. Oh no, wait, no. This one is cosine of theta, and this one is sine of theta. So for A, I did x equal to 1. So just for reference, the absolute value of z is going to be r, and the argument of z is going to be here. And so we're just plugging in everything. So the first one is 1 times cosine of pi. Y is 1 times sine of pi. So then we have x is -1 and y is 0. So the same thing for B, for all of the rest. So I'm just writing down the answer that I got. Oh, wait.
Yeah, that's right.
Oh, I have to write it in Cartesian form.
Okay.
So we're just plugging y and it's x and y. So the Cartesian form is x plus yi. So the form is -1.
So you can just give the final answers for the rest of them.
Yes. So this is the final answer. And then repeat. C is
Wonderful. Awesome. So I'm going to continue. I'm going to do my best. I prefer, obviously, that you continue to learn the proper words for things. I've not said it, but I also have called it the absolute value symbol because that's what we recognize it as when we say the absolute value of z. But what that is the modulus. We have to start calling it that. And our modulus is the same thing as our radius. So we have to start recognizing those in word form. That way, when we see them on the IB exam, we know what they're asking us for, right?
Right.
Cool. Okay, who has the next one? Somebody at home, right?
I did.
Okay, cool.
Can I screen share? Yeah. Okay, so I just have some stuff for reference. So for this question, it says given the complex number, find in polar form. So this one specifically is like in an exponential form, as you can see here. We're going to this polar form. When you combine these, it is cis. So is that how you pronounce it? Okay.
Yeah, I don't care how you pronounce it.
Okay, so for the first one, we have negative z, and then you see from that 7/12 is the radius, the r, and then you put cis, and then your theta, as you can see here, is just going to be the pi over 9, and it's going to be positive pi over 9 because if we see the you see over here like how it's spread out here, that it's going to be a positive pi over 9. And then when you have z asterisk, is that how you say the like?
So the asterisk symbol is called the conjugate.
conjugate, okay, the z conjugate, then you do the same process, but now the theta is going to be negative pi over 9, because we're looking at this graph over here and we see that, oh, the theta, the z conjugate, sorry, is a negative in this area here. And then you do that for the same thing for C. Now it's the negative z conjugate. Is that how you say it? Okay.
Sure.
Yep. And then it's negative 7 over 12. And then negative pi over 9.
Any questions? Cool. Next.
That one's mine here. I'll screen share the problem.
I think I'm still
Uh,
recording. That is good. Yeah, I'm still recording. Okay.
It's still recording, yeah.
Yeah, go ahead.
Mine was kind of simple, honestly. It wasn't as complex as the rest of them. So my first answer, you just multiply the, I guess, coefficients, and then you add the top. So it's 8e 7 by 12 I pi.
Okay, so
Why is it 7?
multiply the coefficients in the front. Any of your r's, no matter what one you're in, you multiply the r's and add the thetas for multiplication. Sorry, keep going, Rohan.
Yeah, that's basically it. So here, I'll walk through it.
Can you just read them all right? Yours is hard to read.
Yeah, do you want me to just read them?
Yeah.
So for the first one, it's 8e I 7 pi all over 12.
Why is it 7 pi over 12?
Pi over 3. Pi over 3 plus pi over 4 is equal to 7/12.
Just fractions, combining like terms. Okay. What was B?
30 cis 135. So literally all you do is 5 times 6 and then 45 plus 90. C is 5/9 E 45 over 14 I pi.
5 what?
45,
45.
yeah, over 14. And then the 45 has the I and the pi attached to it. Yeah. And D is just cis 135.
Because you're 5/6 and you're 6/5, you get 30 over 30 when you multiply.
Yeah, and then when you add the 220 and 275, that's 495. So 495 minus 360.
Everybody good? All right, wonderful. So once you added it, it was a number greater than 360. So in order to find the reference angle, you subtract 360, which is the full circle. Okay.
So we're converting z values to Cartesian form. So we have z, oh, that's not a z. Z1 is equal to over 4. And so we have an R value of 1. So that's already 1. And then we have cosine of 3 pi over 4 plus I sine, where is it? 3 pi over 4 again, over 4. And then and then 3 pi over 4 is, for the cosine, is equal to negative root 2 over 2, and then plus root 2 over 2i. And so what I did was, normally you multiply by the r times the cosine theta value and then the sine theta value, and then that converts it to Cartesian form. And so this is your Cartesian form for that. For space, let me get rid of these guys. So we have that one, that was A.
Next time, just take clear all drawing.
Where's the thing?
Draw.
Oh, this. Okay.
We have to click this little there.
Okay. And then for B, we have to convert Z2, which is equal to -1/2 plus √3 over 2i, and we are converting this to polar form. Okay, and so the r value is equal to square root of -1/2 squared plus the √3 over 2 squared. And so this comes out to be 0.25 or 1/4 plus 3/4. That's just 1 for the r value. And then we have to find the reference angle. And so reference. And so to find that, we divide, we have the √3 over 2, and that is divided, or shoot. To do that, it's tangent inverse of √3 over 2 divided by the half, because it is the y divided by the x value of the z2. And so that comes out to √3 as the half cancels out the 2 in the denominator of the √3 over 2. So then tangent inverse of √3 is equal to pi over 3 for the radian value of the reference angle. And then to find the argument of that, you do pi minus pi over 3, and that gives you 2/3 or 2 pi over 3. And then converting that, you have 1 for your r value. So in polar form, you have 1, and then cosine 2 pi over 3 plus I sine 2 pi over 3. And that's your final answer for Z2 in polar form.
Wonderful. And also in the final form, you could also just write it as cis 2 pi over 3. But yes, that would also be counted as right. All right, next.
Okay, that's me. I'm just gonna share my screen. And I'll just explain my math, even though you might not be able to see it. I can take a picture and send it if you would like. But yeah, okay. So we have Z1, Z2, Z3, y'all see that. Okay, and then for A, it's Z1 over Z2. And so the formula for that would be R1 over R2, and then cis theta 1 minus theta 2. So for A, I did 3 over 4 cis pi over 4 minus 5 pi over 3. And then if you simplify that and work it out, you get 3 over 4 cis, 3 pi over 12 minus 20 pi over 12. And then that simplified would be 3/4 cis over, negative 17 pi over 12. So that's the answer I got for A. And I can repeat that again if you
That's
want.
what she's saying. So this is basically the same thing that Rohan was doing with multiplication, except instead you do R divided by R, and then your thetas you're subtracting. Hers is these at the bottom. So she was doing Z1 divided by Z2. I just,
You want me to?
does that make sense? Everybody okay? Okay, so the one I'd like you to do, Liz, to talk through again slowly.
Okay.
I'd like you to do, it was, you got C, right, when we checked it earlier?
Mm-hmm.
Okay, let's do C. Go ahead and stop sharing. I'm just gonna do it on a whiteboard while you talk. through it.
Okay.
Okay, go ahead.
Okay. Well, I don't have the, okay, wait, hang on. Because I didn't write down the formulas. I kind of just did it. But, okay, so C is Z1 over Z3 times Z2. Do you want me to write, like, say what they are, like what each Z is?
Sure.
Okay, so Z1 is 3 cis 4, pi over 4. And then Z2 is 4 cis 5 pi over 3. And then Z3 is 5 cis 7 pi over 6. Right. And then, okay, so for C, it's like what she wrote at the top. So I just wrote out for Z1, I just wrote that out as it is. So 3 cis over pi over 4. And then for the bottom, for Z3 times Z2, I did the R's for each multiplied by each other. So it's 5 times 4, which is 20, yeah, cis. And then for the angles or the thetas, it'd be 5 pi over 3 plus 7 pi over 6, because you have to add them together when you multiply. So then I got 20 cis, math wise, I got 20 cis, total I got, yeah, 17 pi over 6. And then all of that is, or yeah, it's the Z1 is being divided by that. So it's 3 cis pi over 4 divided by, yeah, what you see at the bottom. And then after you work it out and you do the math, I got 3 over 20 cis negative 31 pi over 12.
Everybody good? So we left these two just are divided, and then you have to get these two, we're subtracting. So we did pi over 4 minus 17 pi over 6. You just have to make sure they have the same denominators because fractions.
Right, okay.
So that's just more tedious. It's not crazy difficult. It's just knowing the formula.
Right.
So multiplication is multiply the coefficients and add. Division is the opposite. It's divide and subtract. Pretty straightforward. Wonderful, Liz. Thank you so much.
Thank you. Okay.
Next.
That's.
Yeah, I
Wait,
think
is it? Yeah. We're on 10C3, right?
I know we're on two.
No,
Are we on
two.
two? Okay, that's not.
So Andrew's got it. Move that.
You got the same thing. Alrighty, so we're trying to find these Z1 and Z2 in different forms into Euler's form. And so basically Euler's form, the formula for that is you want to end up with ending up with the radius, Euler's number, I, and theta. And then the givens are Z1 equals 1 plus I, and then Z2 equals 1 minus root 3I. So for the first one, we're trying to find Z1 over Z2, and first we have to put it in the formula R1 over R2 equals, or not, erase it. R1 over R2 equals, wait, I don't have enough room. Okay, where did I do it? Okay, so first you have to put it in R1 over R2, and then since the R's are both 1, they cancel out, so it's just 1, and then cis, and then you have to plug in the
The R of the second one is not 1.
it isn't.
No, I don't think so.
Second.
Because R would be, do you mind if I just take over?
Yeah.
Okay, so the R for the second one, you do the same thing with the square root of the x squared plus y squared. So the R for the second one would be the square root of 1 squared plus the negative square root of 3 squared. So then we end up with 1 plus 3, which is 4. So R2 is 2. Do you want to come back in?
Yeah,
Okay.
that might kind of change.
That
some
might
answers.
mess up some stuff.
Yeah, so in that case, it would be, drawing,
Yes,
do
the
one
square
over
root, the
two.
first one should be 2, and then it all comes out to 1. That's what it goes.
and then
The root.
cis
Yeah,
and
square
then
root of 2.
with the eyes would it be,
This one is square root of 2. Sorry.
oh,
You actually supposed to say cis, so then what are you supposed to say?
I already talked about it. I don't know. I've had different professors who say different things. I have some that call it CIS.
cis.
I have that. Some people who call it the polar function. I have some people who say cis. I don't care, just as long as you write it right.
And then you're supposed to find theta 1 minus theta 2 for this one. So theta 1 is I, right?
Yes.
Okay. And then it would be minus root 3i,
Or it would be 1.
1.
Theta is tan inverse. So theta 1 would be tan inverse of 1 over 1, which is the tan inverse of 1. I don't know what that is,
Tan inverse of 1.
because 1's not on the unit circle.
Zero point 785,398.
7, 8.
Minus.
Minus.
So that we would follow the same thing. This one would be square root 3 over 1. So what's the tan inverse of square root of 3? I think that's pi over 6.
Of what?
Pi over 6. I think this is,
root 3 over 1.
I
Tan
think this
inverse.
is pi over 4.
Root 3 over 1.
I think it's pi over 4 minus pi over 6.
Okay, wait. So I have, wait, so tan, okay, wait, so pi minus 4, so I got this right?
Tan inverse of root 3 over 1.
Root 3, okay, so root 3 over 1, so that one. So that will be 1.0472, which I believe is even the same as what, like pi, wait, no, pi over. I think
It's the one with 1/2. It's pi over 3.
Yeah,
It's pi over 4 minus pi over 3. It's on your unit circle. Sorry,
Yeah.
guys. So when you do pi over 4 minus pi over 3, you end up with 3 pi over 12 minus 4 pi over 12, which is negative pi over 12.
And then to convert that into Euler's, you would have to do, where is it? It would end up root 2 over 2 e, and then
Yes.
then it would end up as, would it be I negative pi over 12?
Yeah.
Okay.
Perfect. I know that was like a lot.
Yeah.
If y'all have questions about that after looking at it, just let me know. But again, the first step to converting from this standard form to get to modulus argument form, you use the two formulas where it's r is equal to square root of x squared plus y squared, or a plus b, depending on which form you want to use, and theta is equal to the tan inverse of y over x. So I mean, those are the two that you needed to convert. It's easiest when you don't, like these two forms, polar and Euler's form, Euler's form, however you say it, go together really well. The other one does not. So your next lesson is combining those two things even more than what Andrew just got unlucky. He did already have to combine. Like all the questions are combining them. So that is your homework. That video is posted to assign the homework. Make sure you look at that. All right, Bella. Last but not least, finish us off.
So this is like similar to, oh, who was talking about it? I mean, this is similar to the stuff we've kind of already done. It's just more tedious because it's basically you have to convert it into polar form. So you start with 3 over 2 plus 2i, and you have to multiply it by the conjugate in order to get rid of the 2 plus 2i in the denominator. And then when you multiply that out, that comes out to be 6 minus 6i over 8. So then you would just go down here. Can everybody see my cursor?
Yeah.
Okay, so you would just separate, separate out the two numerators, and that would put it in first the Cartesian form. So then you can get it into polar form. So it would be 6/8 minus 6/8 I. And then when you simplify that, it's 3/4 minus 3/4 I. And then you just find your modulus by doing a squared plus b squared equals c squared. And that simplifies down to 3 times the square root of 2 over 4, and that'll be your r. So you've already found a part of your polar form. And then what you do is you have to take, like Leonard was saying, you have to do the tan inverse of y divided by x. And so that's tan inverse of negative 3/4 divided by 3/4, which comes out to be, I can't see it, tan equals negative pi over 4, because I'm pretty sure it comes out, if you were to plug it into your calculator, to be negative 45 degrees. And the reason it's negative is because it would be in the 4th quadrant, because it's positive x and negative y. And so then you would just write cis negative pi over 4. And the other two follow the same pattern, and I have the answers if people want to hear those.
Sure, go for it, Bella.
So it's the square root of 2 cis negative 11 pi divided by 12.
Negative pi over 12?
It says negative 11 pi.
Negative 11 pi. Okay, so that's the next one. And then after that?
It's the square root of 10 over 2 cis 3 pi over 2.
Okay.
I think that's it.
Any questions? Okay, so lastly, I'm just gonna do this on your screen if you don't mind leaving it up for a second, just so we're clear. I feel like IB uses A and B more often, but we see the X and Y as well. So when we're talking about standard form, we learned it as A plus BI. Remember when we graphed them, your I was your Y coordinates and your A was your X coordinates. So this is the same thing as saying X plus YI. Just to be clear, to connect all of those pieces. Cool?
Yep.
All right. Again, you have the next problems. I do have the back of the book answers for those. The sooner you come see me to check whether those are right. This time I wrote down the page number of the answer in the book. That way I know where to find it when y'all come and ask me. But I'm trying, emphasis on trying, not necessarily succeeding, but trying to post these videos earlier. So this one I posted like on Thursday of last week for next Thursday. So like, make sure you get that done before next Thursday. There's no lesson with it because it's just combining this and what we did the first end of the last unit. So it's just combining those two things. There's no lesson. The video is just telling you which problem you're supposed to do on the homework. Cool?
Yep. All
right, that's the end of class. If you're good, you're good. Bye.
Thomas Thompson.
Yes. Bye. Bye, Liz. Yeah. Bye, Sonia.